We are recording. This is the Gateway API meeting for July 12th, and we've got lots to cover today. So again, this is first on the agenda is a V1 Alpha 2 release plan. I wanted to run through this. We've been talking about V1 Alpha 2 for a very long time. And I wanted to actually reach a point where we could have a rough timeline for when we can actually launch this. And I think in our last community meeting, that was end of June, we got to a point where we said, hey, everything we have right now is, we've already discussed all the major topics we want to include in V1 Alpha 2. And we're at the point now where we need to start making decisions based on that. And so based on that, I wanted to try and give a timeline for when we could make decisions for each of these kind of major items. So with that said, first off, as far as GEP timeline, I wanted to, recently we have introduced this concept of gateway enhancement proposals. And the goal here is to help track GEPs and when we can expect them to be proposed, approved, and implemented. So in this model, we have really 3 weeks. The first week, and I'm saying this is week 1, we introduce new GEPs. So there's a couple GEPs I wanted to discuss today at the community meeting in just kind of a time-boxed way, maybe 15 or 20 minutes on each GEP. And then we continue that discussion on the PRs. And the following week, if we haven't already reached consensus and the GET PR is not merged in, we spend maybe 5 minutes or less covering up any loose ends. And then finally giving a yes, no, this is ready to go. And hopefully that's all it takes to get a GET PR in as an implementable concept. And from there, we want to go into implementation phase, where someone can actually take that GEP and turn it into reality within the V1 Alpha 2 API. This is just a really rough concept, but you can see here that I have cross namespace references from routes and policy attachment today. And then I wanted to cover gateway route binding, and I threw in HTTP rewrites for next week. But if there are other things that we want to prioritize here as GEPs, feel free to add them to the list. Feel free to add yourself as a proposer or as an implementer for any one of these. But these are the concepts I'm aware of that we've been discussing and want to get into V1 Alpha 2. So with all that, and with that timeline, you can do some basic math and say, well, hopefully that would lead us to a state where these are implemented and checked in by August 2. Now, obviously, this is not a complete list of everything in the API. We have a lot more than this that we would like to get into V1 Alpha 2. I don't think there's anything major, but there's lots of little small things. So with that said, I wanted to propose setting a goal of August 9 for the actual date that we think we can have everything ready for V1 Alpha 2 and hand it over for the final step of API review. Since we're official Kubernetes API now, we need to go through a bit more process, but I wanted to aim for that date. So 1 week after the final GEP is in and implemented as when we want V1 Alpha 2 to be ready. So I've talked a lot about this. This is just, a process, a concept that I've been thinking about for a bit about how we can actually turn all these broad ideas into actual real decisions and API. And I'm wondering if this makes sense to others, if this timeline seems reasonable. Any thoughts, feedback?
How long is the HTTP rewrites one expected to take?
I will take silence again as good news. All right, let me keep on running here.
Can you hear me,
Rob?
Can you? Or wait,
I can hear.
I
can hear you, Shane.
I can't hear them. This is bad. 1 second.
Rob?
Shane,
I'm on a
I can
new
hear you.
computer.
Okay,
and,
thank you.
Yeah, sorry. Yeah, okay. All right, sorry. I know someone was speaking and I missed it, so go ahead.
This is a travesty, Rob. I can't stand for this. Uh, I was curious about the HTTP rewrites one. We're saying August 9th, but nobody's on that. And like, what's the kind of expected timeline for that one? Because that one's got to be in, right?
Yeah, this one I threw out there. It's an issue that I created a while ago as something that I thought would be nice to have. It's got a few thumbs up or whatever. It seemed like all the other GEPs I've proposed here are rather large in concept and take some thought to get through. HTTP rewrites, it's almost borderline in the sense that it almost doesn't need a GEP. I want to go through the GEP process because we have it now, but it's a simpler concept in my mind. Maybe I'm wrong there. But it's something that we've had as a feature request, and I'd love to get it in if we can. It is one of those things that I absolutely recognize is something like we can add after V1 Alpha 2 is launched. It's going to be fully, additive. It's not going to include any breaking changes, so it's not an absolute need to have in V1 Alpha 2, but I'd like to get it in if we can.
Okay, that answers my question. Thank you.
Cool. I have a feeling I've missed other people saying things, so sorry, but if anyone wants to add any additional feedback on this, let me know.
And I think, Rob, like anyone can volunteer to help lead or co-lead any of these.
Yeah.
We just wanted someone to be the owner in case it was slipping.
Yeah, that's it. And I also, I've kind of started this process off. So I put myself down as a bunch of leads for proposing this and getting the proposal in. But there's an entirely different side, which is taking that proposal and actually implementing it. That's taking all the code, all API changes that are proposed and trying to actually check that in as a separate PR. And if anyone is looking for ways to contribute, signing up in any of these columns would be greatly appreciated. So if you have any bandwidth, it's a great way to contribute. And as I mentioned before, if there are other things that you really want to see included in V1 Alpha 2, try and make sure it gets on this timeline. Yeah. All right, well, we've got plenty else to go through. So if there are no further comments, I'll keep on going. All right, next on the agenda, and I do want to time box both of these, are a couple GEPs I created in the past few days. GEP 709, I think I created on Friday. Both of these GEPs are not going to be new to anyone. These came from docs that have been circulated and discussed before. This cross namespace reference one really includes bits of selection policy, route delegation, cross namespace forwarding. So you can see these are all topics we discussed before, and I'm trying to merge them all together into a meaningful GEP. So with that, let me go ahead and walk through this GEP, and we can take some time to get any feedback that we might have through the process. And thank you to everyone. There's already been some great feedback. I've responded to some, but I am a bit behind. So let me work on that soon. But before I do, I think the easiest way to read through these GEPs is actually in the deploy preview. So this is GEP 709, and this is really trying to merge all these concepts together. And I'll at the outset try and time box this to around 15 minutes, at most 20, but for me that's going to be around 3:30 that I want to end this conversation. So cross namespace references from routes. If you look at cross namespace forwarding, route inclusion, and the reference policy proposal, they're all tackling a similar thing of how can we safely cross these namespace boundaries. These are really common feature requests we're seeing. And in some cases, it's already possible with Ingress, it's just done poorly, and that doesn't always have a good result. And so it's clearly something like users want. and we need to provide a way to do it safely. So based on that, I wanted to see if we could do that with reference policy. This is going to be very familiar to anyone who was on the call with Nick earlier as he proposed that. But the idea is that anytime we allow crossing a namespace boundary, we need to be cautious, and we need to make sure there's some kind of handshake mechanism that requires resources in both namespaces to agree to the reference. And there's a variety of ways to do this, and I'll cover some alternatives in the aptly named alternatives section below. But the one that I think makes the most sense personally is reference policy. Reference policy gives us a great deal of flexibility, and I think it's worth digging into a bit more. So routes will be able to reference services and other namespaces, and eventually include routes and other namespaces. For the sake of scoping this gap in a relatively small this is not small, but it could be larger, I decided to leave out the specifics of route inclusion for a future gap. So I really want to show how this could work for route inclusion without actually getting into the specifics of route inclusion, because then we get into other things like TLS configuration and how that might map with route inclusion and other things that I think feel a little more complicated and might deserve its own gap. But for now, I just want to focus on how this single policy concept can apply to both cross namespace forwarding, that's the route to service in another namespace, or route inclusion. So I'll jump down to this really simplified policy, simplified example. In this case, you've got a forward to, and we're forwarding to a namespace, a service in another namespace. This does not look that groundbreaking, but the idea that you can forward to something like in another namespace is really quite unique in Kubernetes. And so to kind of keep that safe, the proposal is to introduce a reference policy that describes the group, kind, and namespace you trust references from, and to, services within my namespace. So I trust references from routes in namespace foo to services in my namespace. That's what reference policy means. And you can imagine that an admin of a namespace may create these beforehand. They say, okay, well, I trust these specific connections, these specific references. And then their app developers, their route config, whatever, can work within those rules. So I think this is a really powerful concept. And one of the advantages of this over, say, an annotation on service or service import is that we're really thinking about lots of different kinds of backends here. So you can imagine that, service import for multi-cluster, or maybe, I don't know, a storage bucket, or some proprietary backend that we haven't thought of yet. And trying to build in this kind of handshake into all those different resources would be relatively complex. So reference policy allows us to take that out and move it into a different resource that comes with different RBAC, different authorization. And I think it's a really strong rationale. So I've made a few details in here, a few decisions that may not be entirely clear. But before I go any further, I should take a second and ask for if anyone has thoughts before I go too far into this proposal.
Hi, Rob, this is David. Just a quick question. Are you suggesting that the reference policy API would be applicable to non-gateway API use cases?
So yeah, that's we have to be very careful. Thank you for it. And I noticed, I think John also had a similar question on the PR as well. And we have to be very careful about the scope of this. This is intended only for gateway API implementations. But what I am saying is that this could apply to references from gateway API resources to non-gateway API resources. So service is not within the scope of gateway API, but it could be control, references to it could be controlled via this resource, at least from the concept of gateway API. Now, similarly, you think of service import, that's a multi-cluster resource. That's also not really in the scope of this API, but it's something that could be affected by it. Now, I do not want this to become a generic thing that's used across all of Kubernetes. This is very much a gateway API concept meant to describe what gateway implementations should trust.
I think what you mean is, as proposed, you don't want to go there, but if it got generalized, then that's fine. But someone else
that's fair.
does it.
Yeah.
Yeah, I think when I initially thought, I had the same thought, Rob, when I was initially writing the selection policy thing, was like, oh, hey, this might be useful for lots of different types of cross namespace resources. But I think, as Bowie says, it's really important to make sure that we keep this tightly scoped to, we're proposing this for the gateway API only. Hey, maybe if you like the idea and you want to use it somewhere else, that'd be neat. But like the scope of this is for gateway API.
Yep. Good thoughts.
One thing that I had that I haven't looked at this yet, not yet, man. Sorry. But one thing that I thought of a lot when I was doing the initial selection policy one is that the design of the what you actually do for the structs is reasonably important in those from and to stanzas. And I think that to mandate, I originally had the same struct to use for the from and the to, but I think to make sure that it's only this namespace, you actually have to have a different one. So like the to needs to not have a namespace field in it, because the to is always this namespace. And so it's quite important that the to does not have a namespace field. That's
great to hear. Actually, I came across that exact same like aha moment not too long ago. Like, yes, these do have to be different. Yeah, I completely agree. So yeah, just to build on that, I wanted each reference policy to start with a single from and to section. It would be very easy to build a list of lists inside this, but reference policy is similar to network policy and concept in that it's really additive. So each new reference policy, it can't conflict with each other. You're just adding new things that are possible. So given that, instead of creating a single large reference policy with everything that's possible in your namespace, I think it would be more sensible to have lots of smaller reference policies. So although you could have a list of from statements and you could have this entire spec concept as I have it right now in a separate list, I think it's simpler to avoid that. So let me dig into the actual details of this API. There's a from and a to. The from is just exactly as you would think. And it's to describe where references can come from. And the to describes what may be referenced from, for lack of a better term there. Each needs to have at least one item in the list. And if you go down into from, you see that from includes group, kind, and namespace. So it allows you to say, I trust resources. I trust HTTP routes in namespace foo. And then in your to, it would be to reference services. So you just have group and kind. And exactly what Nick just mentioned, you should not have namespace in this scope, because the whole idea of reference policy is you're trusting cross namespace references into your namespace. You should not be able to control anything about references to other namespaces. You're just controlling what can reference you. So that's the concept here. I don't think there's anything too significant deviating from the original proposal here. Correct me if I'm wrong though, Nick. I think this is pretty close to what you...
I think, yeah, it's pretty close to what I had originally, but I think that it is really important to call out that the idea here is that the control point is the person who owns the namespace has to say, yes, I accept references into my namespace. But like there's no control on outbound references. There's only control on inbound references. And the reason for that is that the control on outbound references is expected to be that an object has to reference something that's in another namespace. And right, so the control on outbound references is the actual reference itself. Right, there's no point having an outbound reference policy when it's going to have the same stuff in it as the actual reference itself will have.
Yeah.
Right, so when I was originally noodling about selection policy, I did consider having a thing where you can control outbound references as well, but it doesn't actually add any utility on top of just having a reference itself. And that was one of the things that came up when people were looking at that doc, that a few people sort of said, well, why would I have an outbound reference at all? And I was like, well, yeah, you actually don't need it. You actually only need an inbound reference, and that's what this is intended to do. You only have the policy is the opportunity for the owner of the namespace to accept inbound references.
That is a great way to, I should write that specific summary down somewhere, because that's a good way to describe it. So yeah, I ran through just a few benefits here. It's very similar in concept to network policy and other concepts here. And I think it's fundamentally familiar to users of Kubernetes. I think there's a lot of benefits with this approach, and it's just so much better than another approach I'd considered, which I can get down into alternatives, but just you could annotate all these resources. You could annotate service and say, I trust references from foo or bar namespace, but it just, that gets very messy very quickly. And I think this is just so much better and more flexible. There is one exception I added here that is kind of new. Talking through this and trying to figure out, are there exceptions to this rule? Are there things where reference policy may not apply? And apparently my list formatting did not come through here, so I'll fix that. But there are some cases, I think, and we need to, I encourage a great deal of feedback here. I don't know that we have time to get into the weeds today, but I think there are some mechanisms, especially traffic originating from sidecars, where this kind of reference policy may not make as much sense. And so let's say that there are other mechanisms that may apply. So your traffic is originating from the same place it would otherwise originate, so that you don't need, what we're really concerned about with reference policy is traffic bypassing controls in some way. And reference policy helps us avoid that concern. If your traffic is already originating from the same source it otherwise would, I think there are potential ways you could argue you could exclude, you could create exceptions for those implementations. I don't think that ever applies to Ingress at all, but it may apply to some mesh implementations. And I need to work on the wording here and try and figure out the specifics of what this means. But I recognized as I was writing this out that it doesn't universally apply to all potential implementations of the API, and I need to scope that appropriately. But feedback on this exceptions section is very, very welcome.
So to put that another way, are you saying that in the case that you've got some sort of other compensating control to handle the cross namespace reference, then having a reference policy as well is kind of redundant? Like, if you're already controlling a service to service reference using a mesh policy and doing it via the service's identity, then doing it on a kind of namespace basis as well is actually counterproductive, because it's going to be hard to maintain and hard to keep in sync with the more dynamic config that you're getting.
Exactly. Yeah, this is a generic mechanism that enables this, but we need to recognize that there are other implementations where network policy may apply. Network policy does not traditionally apply to Ingress, but it may apply to, cross namespace, mesh, east-west traffic. It may apply to other, other things. It doesn't apply to all mesh, there's lots of exceptions here. So we have to be very careful in the wording, but that general policy or principle, that something that is affected by other policy or that can be restricted with other policy, this does not need to duplicate that logic. So
it's like something like an implementation may opt out of a reference policy functionality if and only if the cross namespace traffic is controlled in some other fashion. If so, the implementation must document that it does not use reference policy or something like that.
Yeah, exactly. Yeah, that's a good summary. The last bit of this proposal here is adding a namespace field to the forward to and backend ref, and that's really just to enable the cross namespace forwarding. So all of that reference policy work is really just to make this seemingly tiny change. Of course, I think it also really enables route-to-route inclusion in the future and other potential use cases. I think this is a very flexible model, so I'm excited about getting it in. But I've spoken a lot about this. I'm interested in what others think. Is this a reasonable approach to move forward with? Any kind of concerns here?
I mean, obviously, I'm in favor of it since, I did a lot of similar work. And I think the other use case that I have seen in the past, I think John raised a few queries about it, which I think are probably fair, but things that I have seen used are the thing that Contour does with the TLS certificate delegation. Because you can use this for any reference, you can use this to say it's okay to refer to this specific secret object from other namespaces. And so you can use that for a TLS secret that you want to store in a lockdown namespace, but you can refer to the secret in other things. And as long as the controller has access to read it, the person who owns the namespace that's referring to the secret doesn't have to be able to see the secret. So for sensitive TLS key pairs is the Ingress use case that's really useful for. And reference policy as it stands can do that.
Yeah, I agree. I think there's a lot of potential to expand on the potential use cases here. Obviously, this is a relatively small starting point for reference policy, but I think we can expand it a lot in the future. So yeah, cool. Well, already some good feedback that I need to follow up on this PR. But again, this is PR 711. So appreciate any feedback on here, and I'll be active. I really am trying to get this PR in this week, by Monday of next week. And so if at all possible, I would like feedback as soon as possible, just to keep this process moving and make sure we can get V1 Alpha 2 out the door sometime soon. All right, well, I know I said I was going to time box that. Couple minutes over there, so let me run on to 713, which is policy attachment. If that last gap looked big, this one is even larger. So yay. This is policy attachment. This is also really coming back from a doc that was proposed a few weeks, months. I don't know. I've lost track of time, but it's linked in this gap as well. So this one is really trying to standardize policy attachment, and it's somewhat unique in that it really doesn't make many API changes or propose many API changes to Gateway API itself. It proposes a pattern. It proposes an attachment pattern and a few tweaks within Gateway API that can enable that attachment pattern. But this is not as much an API change as it is proposing a pattern that can hopefully work as broadly as possible, so that even though users may be, every implementation may have its own different unique policies that they support, users of this API get a consistent experience when it comes to attaching those policies and moving in between implementations. So with that said, there were really two concepts here I was trying to merge together, because policy attachment is a pretty large and broad scope. One is obviously I wanted to provide a way to attach policy for our traditional Ingress use cases. This is, gateway through to route through to backend service. And from the most simple example, this is you might want to attach a timeout policy or some kind of policy to a gateway, and that would apply to all requests to that gateway. This is pretty similar. This is what you might expect. the big thing I want to point out is that the arrow is from timeout policy to gateway. One of the alternatives we discussed pretty early on is gateway would include a list of policies that it wanted to include. Same with route. But one of the problems with that is we simply did not have sufficient control over service or other APIs that we might want to attach policy to. You think of something like multi-cluster service import, these other kinds of resources, and it quickly becomes difficult if you're trying to create a list of policies in each one of those. So instead, proposing that we attach policies to gateway with this kind of direct policy reference. So this is a fairly simple use case. It's pretty easy to see how this would expand though. You could say, I want to attach a timeout policy at gateway, a retry policy on the route, and a health check policy on the service. These are all kind of made up. I don't know that everyone would have different policy resources for each of these concepts, but hopefully it at least shows the concepts where we're getting at and where different policies might be attached. Now, another more recent potential use case and implementation of this API is mesh. And for mesh, there's a great deal of overlap, between these two use cases, and we want policy attachment to be as similar as possible. So in this case, you look at timeout policy. Well, I want to apply a specific timeout for requests from my namespace to service foo in this other namespace. And so you just create your timeout policy in the consumer namespace and target this service, and it just works. That's the timeouts that apply to users, to sidecars in your mesh, making requests to that service. That's, I think, the most simple example of policy attachment for mesh and how it could work in this world. A more complex example, I think, is this really, let's try and do everything, right? So let's add a route. Let's say we're going to target this service with hostname foo and forward traffic and split traffic, split requests that were intended for foo between foo A and foo B. So you're introducing some traffic splitting, and we want to also apply this timeout policy, which is being attached to the route. That's a lot. I don't know how often you're going to have this kind of complex example, but I just wanted to try and scope out the most complex kind of policy attachment I could think of and throw it together as a potential implementation for mesh. So that's all existing. We've already covered that in previous discussions about policy attachment. What is relatively new here is this target ref API. I went through and tried to sketch out what made sense to include in this target ref, because really so much of this whole discussion is around how you can reference resources, attach policy consistently. Most of this is going to look like your standard everyday object reference in Kubernetes. You've got a group, you've got a kind, you've got a name. These all look familiar. One relatively new concept is a section name. This is the name of a section within the target resource. In some cases, it could be helpful to attach policy to a gateway listener, to a route rule, or to a specific service port. Again, I don't imagine this is going to be the most common use case, but introducing the concept of section name could be helpful here, but I think it can also be helpful in other discussions like the gateway route binding, but not going too far down that rabbit hole quite yet. So that's section name. This would require us to add optional name fields to both gateway listener and route rule. But I think the extra level of detail and level of attachment it grants us could be worthwhile. And then second, this is also considered an extended concept. Namespace is the namespace of the referent. So adding an optional namespace field. This feels like something that will almost never apply to Ingress use cases, which is why I've left it under extended and optional. But what it allows is, let me scroll back up for a second. This example right here, the idea of I want to apply policy to a service in a different namespace, but of course, it only applies to requests from my local namespace. So you're not really doing anything to affect the producer namespace, you're just affecting your requests to the producer. So to make that a little bit more clear, even when policy targets a resource in a different namespace, it may only apply to traffic originating from the same namespace as the policy. So this is a concept that I think is not going to apply to too many implementations, but anyone who's been exploring a mesh implementation of the API, I think this is really intended for you. And finally, the last concept here is class name. There's been some discussion, some feedback I got on the doc about how can we limit what a policy applies to. There are some cases where you may want a policy only to apply to a specific class, a specific gateway class, for instance. Let's say you have a policy you only want to apply to east-west traffic or whatever it might be. I think class name is our best way of representing that. So saying, I want to restrict this policy to only apply to traffic using this specific gateway class seems like it may be our best option here. I'm very open to feedback on this one, but this is the most recent addition in this list, at least in my mind. But I think it gives us a little bit more flexibility when it comes to policy attachment. Okay, so I've talked a lot about policy attachment, and I also wanted to time box this one. So any feedback, any thoughts on this?
One small thing from me that in the namespace thing, you should say even when a policy targets as a resource in a different namespace, it must only apply to traffic. May, if you're talking RFCs, may means can choose to, so must.
You're completely right. Yep. Thank you. Yep.
I just wanted to I guess highlight the class name aspect of this. I think I think it's really useful. I'm wondering to others how they think this might be implemented. Now, obviously, these policies are all controller specific, right? So like generally, two different controllers will not use the same policy CRD because they're all, custom. But a controller might have different, would support different gateway classes. And so I guess the intention here is like, let's say I have an external gateway class, I have an internal gateway class that I would apply the policy to a service. And if that service northbound is exposed through both of those gateways, that policy would only apply to the path that is through the gateway class that's specified here. Is that kind of how you're thinking about it?
Yeah, that's my intent, and I recognize, and thank you for calling that out. I recognize that can add significant implementation complexity, but I do think it's a worthwhile and in some cases necessary distinction to make. But it does add implementation complexity for sure.
I think that it is pretty useful in exactly that use case. In the Ingress use case, it is really useful to be able to say, even for something as basic as timeout policy, right? To be able to say, if you're referring to this, if this is coming from external, then it has this timeout policy. If it's coming from internal, it has this timeout policy. That does seem like it would be useful to me.
Cool.
And I think the only other option that I can think of instead of class name is to use the controller name string, and that has its own set of problems. Class name is probably better.
I actually had controller name first, and I thought, well, hold on, that may not be sufficient. So I went the next level. But yeah.
Yeah, I'd agree with Nick. And controller name would not be ideal from from my perspective as well. It would cause some problems for us. So
Cool.
Yeah, the problem with controller names is too easy to select more than one class.
Yeah.
Whereas name is only ever selecting one class.
Rob, should this be a list, or is it supposed to be?
I thought about that, but I honestly don't know how broadly. I've been trying to keep this as focused and as possible here. So I've also kept target ref to be a single object. And if we need to, there's plenty of precedent for changing a single object into a list in Kubernetes APIs in non-breaking ways. So it's something we could expand to in the future, but I would love to avoid it as long as we possibly can.
Yeah.
I feel like. Sorry, Mark, you go. No, you go.
I was gonna say, I think that like how this will end up getting used will depend a lot on how all the implementations, like the shape of their service policy CRDs, like how shared are they amongst gateway classes? What's the granularity? Like, I know that like we've talked about it internally for GKE that like there's definitely a balance. We certainly don't want a service policy resource for individual fields, like kind of the examples, like we'll make them as big as possible that it makes sense. Like we have a whole basket of features for CDN. We have a whole basket of features for cloud, cloud firewall. And those worth kind of thinking would each be its own CRD that has like, anywhere from like 5 to 20 fields or something like that. And not clear whether how much they would be shared between different classes, right? Like our external load balancers support all these WAF capabilities. The internal ones don't have the same capabilities. We probably would want to reuse the same CRDs, and some of the fields just wouldn't be relevant for some gateway classes. And so if there is a high degree of sharing between, then that probably points towards we'd want to make this class name a list. If there isn't, then it'd probably be easy for it to be just an individual class name. But yeah.
Yeah, that's a good distinction.
Yeah, I thought, as Rob said, I think that it's probably safer to start out as a singular and turn it into a list than to go the other way.
Yeah, you can always get more complex. I agree.
Yeah. I think, in terms of Contour, like we already have inside HTTP proxy, we already have timeout policy, load balancer policy, health check policy as like structs on their own. So we will probably be just lifting those and turning them into CRDs for this sort of thing anyway. And to be honest, there's a good chance I'm going to lift this whole thing and bring it into and make it work with HTTP proxy as well. Because then it's the same mechanism.
Yeah, that'd be awesome. Cool. Let me keep on running. I know I wanted to, we're running out of time on this one. Just take a couple more minutes. I wanted to propose a new policies field that would be added in status for gateways and routes. This seems like, at least to me, it would help provide visibility, but John has already pointed out in the PR that there are some limitations like that from this. One, it's a scale limitation if you have tons of policies applied. But two, what I was originally thinking here is this would apply to policies that directly referenced a route. So route.policies includes policies that have been directly attached to that route. But since we're talking about hierarchy and some concept of inferring defaults from above, a policy status may become confusing in the sense that you only see your tiny little local piece of the picture, or alternatively, you see a really huge, overwhelming list, neither of which seem great. So I don't actually have a good solution to this one yet, but that is some limitations of a policies field on route or gateway status. So if anyone has thoughts on how we can address those concerns, I'm open to them. I want to jump ahead, actually. The other way that I've proposed making this a little bit simpler to understand is a kubectl plugin. If all policy CRDs are following the uniform pattern I've outlined above, and they all have a shared label, it becomes relatively straightforward to build a plugin to actually visualize what policy applies to any point in your stack. And I think that's a really powerful concept, something like that would be harder to achieve with any kind of status or anything else. So I don't know that these are necessarily mutually exclusive. I propose both of them, but if the policies field becomes too unwieldy, this is an option we can fall back on. It's not like we have nothing. Yeah.
I think in terms of status, it's a good idea to crib from the idea of conditions here and say you can subclass you can embed the core definition of like what a policy is, as long as whatever you have duck pipes back to these, has these fields, and you can duck pipe it back to a thing that is referenceable, then a kubectl plugin will work, or anything else can also infer information about the CRD even without knowing the full spec. So I think, if we can design this API to be able to make use of duck typing, then that will make the API easier to be parsable at a machine or human level.
Yeah, agreed. I think if we have a consistent structure, which I think this spec outlines reasonable, it would be consistent enough. I think you could get some pretty useful information out of a plugin, out of some kind of standard way of interpreting policy. And I think that's going to be universally helpful to all implementations of this API. Yeah, so there's a lot more in this gap. I don't have time to get through all of this. I do encourage everyone to take some time to look through and read through any of the details on their own. One other section that I would say is new is this interaction with custom filters. At this point, had a brief conversation around this, I think with Harry, about how this could interact. And there's definitely a lot of overlap between a policy attaching to a route and a filter within a route pointing out to a custom resource. They're a very similar concept. And what I have suggested right now, proposed right now, is that there should be no overlap. So if something can serve as a filter, it should not be a policy. And if something is a policy, it should not be a filter. There is certainly room for merging those concepts, but if we do, we really have to figure out how things like precedence and hierarchy actually work. For now, I think it's simplest to consider them separate concepts that don't overlap. But again, this is all a PR still, so very, very much appreciate feedback on this.
I think that should go for anything, and maybe we should make it more generic. Is anything, like, for instance, weight. You could make an argument, well, maybe weight isn't a good one, but I'm sure there's other things that are first class in the API today that could be in the service policy. Nothing should ever be in two places, because within the service policy, there's a clear hierarchy that shows how to treat it if it's configured in multiple places, but not so if it's anywhere else in the API. But I think that things should trend towards going first class in the API if it can be done, because being first class is always the most streamlined workflow. And if that is a common workflow, then that's going to be the easiest way to configure that thing.
Yeah, completely agree. Let me run up here to one other point I want to highlight. So there's another concept in here, which is that of hierarchy and overrides. This one, I think, is also going to require some more attention. The idea that it's really similar to, I think Mark originally proposed it, the allow override concept. So I don't think enforce is the correct word here, but what I'm trying to describe here is essentially the inverse of allow override. Let's say no override. I don't know, maybe there's a better term. But basically these two structs that can exist in any policy resource, and when they exist, our plugin or anything interpreting policy resources would understand that anything below this in our hierarchical model cannot override this specific value. What this does not mean is it, if something is already enforced a layer above this, that is what it is, right? You can't, this is really just saying nothing below can override it. It's not talking about anything above in the terms of hierarchy. So this is really coming back to that allow override concept, just in a different way. I think this is not the right term though. So suggestions very welcome for naming on this one, or other ways to handle this.
You could just call it override.
Yeah.
Required.
Sorry.
So I started with required actually, and came full circle with the stop at final and then in for it's been around. But yeah, something like here, suggestions.
Even that it's don't not allow override.
Yeah. Yeah.
Okay, that's it. That's the one.
Enforce is actually pretty good. I mean, I don't see a problem with it.
I think the biggest concern with enforce that I had is that someone may attach a policy at some kind of low level that could be overridden above, and they may look at enforce and say, well, I know this is going to be true. Whereas something like, let's say, no override, a bad name, but it's clear that this just means nothing. Well, even that's not a great example, but if we had a name that was clear that nothing below this can override it, but anything above can, that's my biggest concern. A name that suggests that this is for sure guaranteed to be the case.
That's why I suggested override, because override overrides the things below it, but not can be overridden by the things above it.
What was the name specifically?
Just override, because override overrides the things below it, but can't be overridden, and can be overridden by the things above it.
I agree with that one. I was going to suggest constant, but I agree with the rationale.
So it's just, so literally it is, so you are overriding CDN, in this case, you are overriding CDN enable true for any for any descendant policies. But you can override and override, right? Like, because if you're higher up the tree, then you get to go first, right? Like, and so the way that you process this tree of policies then is that you take overrides from high up, and they get blasted through, like they get blasted through all the way down, and then you take any defaults that are left over.
Yeah, actually, I like that. Okay.
For that matter, you could
I'll run
be
with that unless I hear
completely
any.
explicit.
Sorry, go ahead, Micah.
Call it. You can make it completely explicit and call it override descendants.
Yeah.
Okay.
I'm gonna spell that wrong a lot though.
Override child.
Yeah.
Yeah, I agree that there's some level of ambiguity when it's just override. I mean, if you're familiar with the model, you recognize that override is overriding things below you, not above you. But if you had some concept of directionality in there, like override child, maybe that helps. But the longer the name, the greater likelihood of typos. So, yeah. Okay, well, we have blown past my time box on this one, but some great feedback all around here. Again, I'm really hoping that we can get these GEPs in the next week, the next 7 days. That means I'm going to try and be as responsive to feedback as possible, and just trying to move on these as quickly as possible, because as a reminder, my goal here is to get both of these GEPs approved July 19 and then implemented and merged in by July 26. So any help we can get along the way through feedback and just consistently digging into these PRs would be great. I do want to make kind of concrete decisions and just have these timelines be relatively firm, just so that we can actually make some progress, make some final decisions, and get V1 Alpha 2 moving again. So yeah, that's my goals. Feel free to suggest different timelines for anything, but this is really what I would prefer in terms of getting things out the door. And with that, I would love to get to PR and issue triage, but I think we are just out of time. So thank you everyone for the great discussion on this.
Cheers.
Thanks.
Thanks, Rob.
Thanks,
Nice
Rob,
job.
as always.